Welcome to video 7.1 part 2, one sample significance tests. So in the previous video we had an example of a proportion, a significance test for one sample proportion. So this one, let's take a look at our scenario. So last year an AP Stats class spent an average of 25 minutes. So right there, it already said the word average, so you start thinking means. An average of 25 minutes a night on their homework. Their teacher randomly sampled 30 of her students this year to see if this average had gone up. The sample mean of 32 minutes spent on homework each night and the standard deviation of 11 minutes. Do the data provide convincing evidence that AP Stats students spend more time on homework per night this year than last year? Okay, so it is a sample. We're talking about means and standard deviations, so we definitely are talking about a means problem here. So when we go to define our parameter, we need to use the notation for mu. Now, what are we looking for? Do the data provide convincing evidence that AP Stats students spend more time on homework per night this year than last year? So what we're really looking for is what is the true mean time spent on homework by AP Stats students this year. So, how's the sound? The true mean time AP Stats students spend on homework each night, and it is in minutes, so we want to make sure we make mention of that this year. Okay, so that's our parameter, what we're trying to decide. So, last year students had 25 minutes. So, we're going to say our null, that the true mean, that is just going to be the same. There's no different from last year's students. Our alternative, remember we have choices. We're going to make this one be greater than 25 because the sample said they had a mean of 32 minutes. So we're thinking it's actually more than the claim of 25 from last year. This is not earth-shattering. Nobody should die from this, so it might feel like it sometimes, but we should have an alpha 0.05 here. Now, my statistics, there's a whole bunch of stuff. I'm just going to pull it out. You could have pulled it out up here while you're reading it. Some people like to write it as they're going. So we had a sample mean of 32. And then we had a sample standard deviation of 11. This is a means problem. That means we're going to be doing a t-test. So that means we've got degrees of freedom. And so the sample is of 30 students. So our degrees of freedom will be 29 here. All right. So here's our state. Let's go on to our plan. We said it was one sample when we were reading through. Sample had a mean. So it's a one sample. We have to do t, so t-test for, and we're trying to estimate the population mean here. Okay, so let's check our three conditions. We had our random. It does say randomly selected 30 students. Then our 10%, because we are sampling without replacement. So this can be a little hard. So what we're going to say is, because this is saying she has 300 AP Stats students, maybe there are 300 AP Stats students total. Maybe they have more than one teacher teaching AP Stats students. So 30 is going to be less than or equal to 1/10 all AP Stats students at this school. Okay. And then normal, because we're talking means, we have three choices. We can either have the population is normally distributed, but it doesn't mention that, so it can't be that. Then we look at sample size, and we're good here because our sample size is 30 which is greater than or equal to 30, so we have the central limit theorem helping us here. You can only have central limit theorem for a means problem. So our state and plan are done. Let's go ahead and go on to the do. So this is a t. Our test statistic will be a t. You're going to take your statistic minus your parameter and divide it by the standard deviation. Now, we took a sample, so you got to remember to do this. So before we go any further, I want to draw a picture. So the claim is at 25, so that's what we're going to put in the center. We assume the null is true, so we're going to use it. This is a t distribution with a degree of freedom of 29. Okay, the score that we were interested in is 32 or more. All right, so I'm expecting a positive z-score. When I calculate this out, I got 3.49, which gave me a p-value of 0.0008. A very tiny p-value. And your 3.5 standard deviations, remember your empirical rule where 68% of the data is within 1 standard deviation, 95 within 2, 99.7 within 3. So we're more than 3 standard deviations out. So I expected a very small p-value. All right, I want you to try the conclusion on your own and come back to see how you do. Remember to include your 3 components of interpreting the p-value, make a decision on your null alternative, and then make a conclusion about your alternative. All right, assuming the true mean equals 25 is true, that's your null. We're assuming it's true. There is a 0.0008 probability of getting a sample statistic of 32 minutes, and really I should include or greater in there, purely by chance. Because of the way we shaded, I gotta have or greater. Because 0.0008 is less than 0.05, we reject the null. We have convincing evidence this year's AP Stats students are spending more time on homework each night than last year's students. Hopefully this was helpful. Let me know if you have any questions, and I'll see you in class.